Before I start, I think let me give some background that how I started with this. A couple of months back, Professor Bhalekar wrote me regarding this Professor Santilli's mathematics. And then he gave me suggestion that it's a good idea if you want to learn really the isomathematics and this Santilli's mathematics, that Professor Santilli would himself be here delivering the lecture. And then I have written my clear intentions to Professor Koda, and Professor Anderson gave me the indication that being chemist, you start with this topic, preparing this topic. So I had this opportunity to stand here. And for this, I must thank the Santilli Foundation for supporting me, and especially Professor Santilli, Mrs. Santilli, Professor Anderson, Professor Koda, and of course Professor Bhalekar for guiding to take this topic in the forward direction and to learn this. So to start with, I'll be just going through what the hadronic chemistry I could understand right now, that I'll be going through, and these are the topics and conventional hadronic chemistry coverings that we will be going through. Although based on the axioms of quantum mechanics without ad hoc adulterations, I think quantum chemistry has proved its majestic axiomatic consistency throughout the 20th century and provided invariant results without any internal inconsistencies. But despite its majestic axiomatic consistency, it still remains affected by a number of insufficiencies that are given by many scientific workers in the field. And the claims which quantum mechanics gave, followed by the postulates, were like the particles can act like wave and they can interfere with themselves. There is always a non-zero probability of finding a particle essentially anywhere in the universe. Measurement is inherently probabilistic. No supplement knowledge will make the measurement deterministic, and so more. So the scientists, those who were working in the field like Niels Bohr, Professor Einstein, then Professor Heisenberg, Dirac, and all those, they have always a doubt of the completeness of the theory. In the philosophical writing of Niels Bohr in 1998, we can find he has written, anyone who is not shocked by quantum mechanics has not probably understood it. Professor Einstein himself has written it like a real black magic calculus, and in his letter to Max Born, he has written on quantum physics that quantum mechanics is certainly imposing, but an inner voice tells me that it is not yet the real thing. Quantum theory says a lot, but it does not really brings us any closer to the old one. I, at any rate, am convinced that God does not throw dice. This is a very famous one. And obviously, Professor Fermi's doubt that whether quantum mechanics really holds inside the mesons was the, I think, basic foundations of the Professor Santilli's work. And then later on, with the advancement of experimental and technological efficiencies, the increasing number of limitations of quantum mechanics was surfaced out, which I could found from the literature of the Professor Santilli's. And those were, let us go in short with the incomings or limitations of the quantum mechanics, and or in short in quantum chemistry. So likewise, it does not characterize an attractive force among the neutral atoms, say of hydrogen molecule. Why hydrogen and water molecules admit only 2 hydrogens and not 3 or more? Characteristics like binding energy, electric and magnetic dipoles, multiple movements of hydrogen and other molecules have not been represented correctly. Larger percentage are missing in the representations of electric.
Can you speak a little bit slower? Otherwise we have difficulties at the stage.
Yes, yes, thank you, thank you, thank you.
I want to understand.
Yes, yes, thank you. So this is what I have tried to summarize the limitations what have come in front of us with the advancement of the experimental and technological efficiencies of the quantum chemistry. That I have tried to summarize it over here, I have taken it from the literature. It does not characterize an attractive force among the neutral atoms of hydrogen molecule, or why hydrogen and water molecule admit only 2 hydrogens and not 3 or more. Characteristics like binding energy, electric and magnetic moments, multimole moments of hydrogen and other molecules have not been represented accurately. Larger percentage are missing in the representation of electric and magnetic moments, and sometimes even have the wrong signs. More so if you go to see the justification for introducing the ad hoc function, that is this one. So quantum chemistry could not justify the introduction of this function, and because of this, it causes the major departure from the unitary structure of the quantum mechanics, which cannot be accepted. Then if you go further, and we see its ability to deal with the complex structure again, so like multi-body systems like water molecules, which are non-linear, where the superposition principle is inapplicable, with consequential impossibility of formulating the consistent factorization, which is given by equation 2, and this impossibility expresses the inability of quantum chemistry to deal with the complex structure. Then likewise, quantum chemistry being reversible, it indicates the spontaneous decay of water, that is impossible, and that is the serious drawback of the theory. If you go further, it gives the poor convergence of perturbative series, that is the again additional rather crucial limitation that has been given, and the insufficiency here referred to is given by the fact that the time requested, for basic calculation by large computers are generally excessive, thus implying the inherent lack of a strong convergence of the perturbative series with a consequential debatable accuracy. So with this and all other limitations, Professor Santilli never accepted the quantum chemical notion of the valence bond. For him, it was obviously the nomenclature without the quantitative scientific content. Now, to have a quantitative scientific content of a valence bond, it must satisfy the following conditions. These are mentioned 1, 2, 3. That the force between a pairs of valence electron and its physical or chemical origin, that has to be found out. The force must be attractive one. The attractive force must verify the equivalence of binding energy and other data. Now, quantum chemistry could never verify the above conditions. On the contrary, according to quantum mechanics, identical electrons repel each other and certainly they do not attract. And therefore, an idea of constructing a quantitative invariant representation of deep overlapping of the wave packets of valence electron motivated Professor Santilli to construct the hadronic covering of quantum chemistry, capable of resolving all the issues of insufficiency, and now it is christened as hadronic chemistry. So now, in hadronic chemistry, we study a completion of quantum mechanics, see the completion of quantum mechanics and not the new theory, and chemistry via the addition of effects at the distances of the order of 1 femtometer only, that is very small distances, and above such distances, the quantum chemistry has its own structure, which are assumed to be non-linear, that is dependent on the powers of the wave functions which are greater than 1, non-local integral, dependent on the integrals over the volume of wave overlapping, which as such cannot be reduced to a finite set of isolated points, non-potential, that is consisting of a contact interaction that is caused by physical contact, non-Hamiltonian, that is which are not representable by Hamiltonian and thus requiring additional term, and consequently non-unitary. That means the time evolution violates the unitarity condition that is given by this. Now note here that the unitary condition, non-unitary condition is necessary because the quantum chemistry would be fully within the basic axioms under the unitary representations. And therefore, finally, with the mathematical maturity of hadronic mechanics, Professor Santilli and Ciladi, for the first time in their historical papers in 1999 and 2000, have proposed new models for the structures of hydrogen and water molecule, which apparently for the first time could give. It have introduced a basically new, strongly attractive non-Coulombic force among pairs of valence electrons. First time explained why these molecules have only 2 atoms per dimer in case of water molecule, achieved an exact representation of binding energy from unadulterated first axiomatic principle, and proved the reduction of computer time by at least a factor of 1000-fold. And now Professor Santilli has said that this factor has more than 50,000 folds, maybe. These studies then hadronic chemistry categorized into the following branches. The quantum chemistry, obviously above the distances for the particle bigger than say 1 femtometer or 10 to the power minus 13 centimeter, quantum chemistry is equally applicable. Then isochemistry, which we are going to deal with in this presentation right now, is characterized by the Lie isotopic time invariant and axiom preserving non-unitary covering of quantum chemistry is in this. Then genochemistry is characterized by Lie admissible time invariant covering of isochemistry. Hyperchemistry characterized by multi-valued covering of genochemistry for the representation of organic structure and the processes. And isodual, iso, geno and hyperchemistry characterized by isodual map of integrability conditions for the existence of Lagrangian or Hamiltonian, for the description of the chemistry of antimatters of course. So now let us look how it has been applied to hydrogen molecule. Before that, this is what is the central part of the hadronic chemistry, the structure of isoelectronium. Now this isoelectronium, the hypothesis made here or the assumption made herein was that the pair of valence electron from 2 different atoms bond themselves at a short distances into singlet quasi-particle state, which is called as isoelectronium, and which describes the U-shaped. If you look at this, this is U-shaped structure, which is shown over here. This then became the necessary condition to justify the character of hydrogen molecule is not paramagnetic, in total agreement with the experimental verifications. Therefore, it is needless to say, once 2 valence electrons are bonded into isoelectronium, there is no possibility for bonding additional atom, justifying why hydrogen or water molecule admits only 2 hydrogen atoms. And then the fundamental problem of verification of the 3 conditions that which we have mentioned earlier regarding the force, attractive force. The Professor Santilli and American scientist Professor D.D. Ciladi in their historical paper has mentioned over here. So here we are starting with this, and let us consider the conventional quantum mechanical equation that is given over here, where m is the electron mass, and the above equation shows the repulsive Coulombic force between the point-like charges of the electrons, but the electrons have extended wave packets of the order of say 1 femtometer, whose mutual penetration as necessary for the valence bond cause non-linear, non-local and non-potential interactions. The only possibility for an invariant representation of bonding of the hydrogen electron with the valence electron of another atom of generic charge, say Ze, is to exit from the class of unitary equivalence via an isounity transformation, and this is given by the construction of this iso unit, U cross U dagger, and this has been known as Santilli's iso unit, and its inverse also it is given, the isotopic element, that is this U cross U dagger, its inverse, its isotopic element. And its generic multiplication between the 2 quantities is given by equation 5 and equation 6. This is shown over here. I really want to thank Professor Santilli for the yesterday discussion regarding this multiplication. I had a little confusion regarding this. but now after the discussion it got very much cleared. So with this iso lifting of the original conventional quantum chemical equation, it has got the final structure like this. With the factor, the isotopic element T in the first Coulombic term, here it is, originates from the non-unitary transformation of our previous equation, while the same factor is absent in the second term because latter is the long range one, or it may be the merely trigger one, thus being conventional. And obviously the change in the energy value is given over here because of the due to its general non-commutativity and Hamiltonian of the iso-Hamiltonian and the iso unit. And then let us recall from the foundations of hadronic chemistry the structure of iso unit. This is given by the volume integral like this, equation 8 is given over here, where psi and psi isotopic wave function, that is psi is the usual wave function and height with this psi is the iso wave function given over here, and its expansion is given over here 1 plus this, and its isotopic element obviously its expansion would be like this. And then from this two conditions, from 8 and from 9, we could obviously get this thing because this volume integral given over here is much greater than 1, is much greater than 1, and therefore we could get this condition. These are the very basic condition to prove the fast convergence of the series, isn't it? And that becomes a very, I am very fascinated with this kind of mathematics because this has in a very simple way the fast convergence of the perturbative series. And now this limit above 1 femtometer, see, for all mutual distances of the valence electron greater than 1 femtometer, the volume integral of the previous equation is null, wherein hadronic chemistry recovers from the quantum chemistry, isn't it? So note also that the explicit form of the normal wave function is given over there, and we have represented for the volume integral in the previous equation, and we have taken the radius is equal to 1 upon b, and the iso wave function is defined in this fashion, which is given. Again, m is the constant under the hadronic horizon, and here one can see the emergence of the Haldane potential, which is attractive one, and this Haldane potential is known to behave like a Coulomb one at a short distances and much more stronger than the Coulombic one. And therefore, if we see the Coulombic term of our original equation 7, let us go back to equation 7, this one, this part I am talking about. This part will give you the emergence of this type of term, which will give you the total absorption, reflects the absorption of the repulsive Coulomb potential by much stronger attractive Haldane potential. And in this way, Santilli and Szilárdi strong valence bond achieved for the first time in the history of chemistry a valence coupling between two identical electrons in a singlet coupling with a strongly attractive force. So this has now taken with the taken for an isochemical model of a hydrogen molecule with the assumption of a stable isoelectronium. And again, the conventional quantum chemical equation has been taken in equation number 20, that has been shown over here, and below it the reference has been shown from where it has originally taken. And here this is the conventional part. This R12 is the distance between two electrons. 1 and 2 represents for 2 electrons, A and B represents 2 protons, and this capital R represents the distance between 2 protons. And this is basically the schematic representation given in the literature for this, what I have taken. Again, the representation, this quantum chemical, conventional quantum chemical notion or equation does not admit any analytical solution. It misses at least 2% of binding energy, and predicts that hydrogen molecule is paramagnetic due to its evidence impedance of the independence of the electrons. Therefore, again the task is to lift it from the isochemistry and subjecting the above model to the non-unity transform. For this again we will use the iso unit, this is given by this, and we will use the non-unitary lifting in this fashion, where it has given that the distance, for the distance greater than 10 to the power minus 10 centimeter, the isounitary will cover the quantum chemistry, and therefore the isochemical model coincides with the conventional model, except everywhere except for the small contributions at small distances. And these are the Hilbert space of system that are given over here. Now, this iso unit has taken, or consideration would non-unity transform under the consideration would act only on the distances of between the two electrons, the interaction between two electrons which are deeply overlapped, and the variable other variables are remaining unchanged from the conventional quantum chemical equation. And the simplest possible solution is given by this iso unit, and again this is the same volume integral equation that we have seen earlier. Again psi has the conventional meaning of wave function, and psi hat represents the iso wave functions. And then its non-unitary lifting has given us this form. Look at this term. This has given, this whole equation has a quantum chemical notion, no doubt, and this has lifted, and this has given the emergence of the Haldan potential, which is much more attractive than the Coulomb one in the small attractions, small region, isn't it? This shows, they're showing the effect of Santilli-Shiladi strong valence bond of the Haldan type, and that absorbs all the Coulomb potential. The equation also explains the reason why hydrogen molecule admits only two hydrogens and provide exact representations of binding energy and other molecular characteristics. Now, a fundamental implication of hadronic chemistry is that of restricting the above four-body model to three-body structure, evidently composed of two protons at mutual distances r, and the two valence electrons strongly bonded into isoelectronium quasi-particle. So now in particular what we have done, the assumption that the two electrons have overlapped up to the full extent, and the overlapping is such that the distance between the two electrons is approximately 0, and therefore this R12 is taken like this, and moreover the hydrogen nuclei are about 2000 times heavier than the isoelectronium. Therefore, the model of equation 27, the original quantum chemical structure, can be reduced to a restricted three-body problem, two protons and isoelectronium that has been taken, just like for the hydrogen ion and not for the hydrogen molecule. Again, by recalling the Haldan potential behaves at small distances like a Coulomb one, and therefore the isochemical model of hydrogen molecule as three-body system can be written like this. This system does admit an analytic solution in its restricted form under the assumption that the isoelectronium is stable, and again as we can note that this equation is a pure quantum chemical because all the distances between the constituents are much bigger than 1 femtometer. Excuse me. It is also interesting to note that the above model can be used for the study of bonding of hydrogen atom to another generic form such as hydrogen and oxygen, thus permitting again for the first time the novel exact calculation on the water as HOH bonding, namely as two intersecting isotopic bonds of hydrogen oxygen and oxygen hydrogen, each admitting an exact solution with possible extension to molecular chains and extensions to other molecules. And therefore, this has been taken, and this is the proposed water molecule. If you can see, the hypothesis was that the two electrons, one per each pair of hydrogen and oxygen correlates themselves into bonded singlet state at a short distances, resulting in two isoelectronia, that is one per HO dimer, hydrogen oxygen dimer, and the bonding force between the two hydrogen and oxygen atoms was justified by Haldan force between the two valence electron in the isoelectronium. Therefore, the binding energy is characterized by two isoelectronia or two U-shaped orbits of the isoelectronia around the HOH nuclei, and the molecule itself is characterized by two isoelectronia, that is one per each hydrogen oxygen dimer, isn't it? And this obviously has exact solution we can have as a three-body system. Now, the approximation that the hydrogen-oxygen-hydrogen molecule as being composed of two intersecting identical dimers of hydrogen-oxygen with evidently only one oxygen requires the first correction due to the lack of independence of the said dimer. Moreover, in each HO dimer, we shall assume that oxygen appears to the isoelectronium as having only net positive charge of positive located in the nucleus. This evidently requires the second correction, which essentially represents the screening of various electrons of oxygen. And herein, the additional hydrogen atom bonded with the first hydrogen-oxygen dimer can be represented via the non-unitary image of the Coulomb law resulting in the screening of Gaussian type, and this is given in this fashion, where the factor 2e originates from the duality of the bonds and alpha is the positive parameter. By denoting again 1 and A for the electron and the neutron of the hydrogen, and 2 and B for the oxygen, and assuming the absence of all hadronic effects, the conventional quantum chemical equation can be written like this. This is the same one as we have seen in case of hydrogen molecule. Again, for its lifting, non-unitary lifting, we can use the ISO unit below the distance of 10 to the power minus 10 centimeters, say, and above which the quantum chemical notion regains. This is the only possible solution for this, and the ISO unit is given by this volume integral, and where the psi represents the conventional wave function and psi hat represents the ISO wave function. And again, the fundamental condition of fast convergence as given by Hadronic chemistry. Thanks for this chemistry that it has given such a wonderful condition, and that exists. That T is much less than 1, and therefore again we can see the as in the case of hydrogen, we can see the non-unitary transformation of the equation, previous equation. This is the emergence of the Haldan potential, which absorbs all the other Coulombic potentials, and the model can be subjected to an important simplification under the assumption that considered herein, that the hydrogen-oxygen dimer in equation, the previous equation, can be reduced to a restricted three-body problem that we have taken as we have assumed in the hydrogen molecule, and that has been taken over here. And further, if we go ahead, the liftings that we have considered due to the screening of various electron in the oxygen and other corrections needed in sensing of the oxygen nucleus by the isoelectronium as well as by hydrogen nucleus, then yields the isochemical model of the water molecule. And this is given by question this equation, and these are the term because of the screening, and this E is the half of the binding energy of the water molecule, where R is the intra-atomic distances. Now, under this approximation plus the assumption that the isoelectronium is stable, the previous equation constitutes the first model for the water molecule, admitting the exact analytic solution from the first principle in scientific history. Being exactly soluble, the previous equation exhibits the new explicitly attractive strong force among neutral atoms of the hydrogen-oxygen dimer, which is absent in the conventional quantum chemistry. And the equation also explains the reason why the hydrogen molecule admits only 2 hydrogen atoms. The model yields much faster convergence of the series with much reduced computer times and resolves many other insufficiencies of quantum theory. And finally, the model is evidently extendable with the simple adjustment to exact solution to other dimers involving hydrogen, such as hydrogen and carbon. This is what the conclusion that has been taken out from the overall study. Again, the same. The molecular structure study based on the bonding of a pair of valence electrons from different atoms into singlet quasi-particle has provided the route to overcome the 20th century insufficiencies in quantum chemistry, namely the exact representation of molecular binding energy from the first axiomatic principle without any adulterations. Gave the explanation why hydrogen molecule has only 2 hydrogen atoms. Obviously, this has given the reconstruction of the linearity of Hilbert-Santilli isospaces over Santilli's isofield, and which is achieved by this lifting, and restores the superposition principle with exact factorization. This is given over here with consequential validity of isotopic theory for complex molecules or complex systems. And this is again the same thing that we how the system converges fastly because of the very much smaller value of the isotopic element and very high value of the iso unit that has been given over here. And continuing to this open end, the separate genochemical and hyperchemical models are also developed, which are not obviously the part of this presentation. And this one is useful for the geno and hyperchemical models are useful for the reversible representation of the synthesis of water, and latter one is given the multi-value, that means hyperchemistry is used for this. And therefore, to conclude here, indeed, by the virtue of this isochemical branch of hadronic mechanics, we have overcome almost all the insufficiencies of quantum chemical notions, and this tool is indeed the promising framework that would help explore many more macro and micro level inconsistencies of existing literature that one way or other help mankind. Thank you for your patient listening, and thank you for providing an opportunity to stand in front of you.
You have made the most beautiful presentation of the topic that I have ever heard.
Thank you.
Thank you.
Thank you. Thank you, sir. It's I'm feeling honored that you have given a chance and opportunity to come all the way from India to here, and I could witness such a wonderful scientific interaction over here. And definitely, sir, this would be very much helpful for me in again going in the field ahead that I am looking for the progress in the field.
Thank you. I listened carefully to every word that you said, and I do not have no criticism, because at least everything that I heard is as published. And I only want to clarify that what you indicated, but stress that we use isochemistry because the hydrogen and water molecule are stable. Being stable, they are reversible over time. Therefore, isochemistry is appropriate. Yes. Chemical reaction, no, you cannot use isochemistry to go
we need to go exactly for genochemistry.
Yes. Also, just a marginal suggestion, when you derive the Halton potential from the by using the iso unit that you correctly represented, make sure that you use what I call the Animalus-Santilli mechanism. Namely that everything is under unitary transform except the Coulomb interaction from the nuclei, since it's long range, is not hadronic, it's quantized. Yes. So it's added. When you do this, when you use this Animalus-Santilli mechanism, then you derive rigorously.
Yes, I'll definitely.
Yes, but I'll send you the link to my own presentation in the event can be helpful. But
I would be grateful. I would be
but
grateful.
again, I don't believe, it's been so nice that I don't believe. So,
Thank you,
Thank you.
Thank you. Has anybody any question?
I want to talk to you.
Yes.
Yeah, okay.
I have one question related with the hydrogen molecule, the model you solved, but you didn't present the results of the numerical analysis.
Yes, obviously, because I have started this study a couple of months back, and when I had returned this, my intention to Professor Anderson, so he said that no doubt you initiate, no doubt your presentation may not contain any mathematical illustration and any numerical part, but then you can initiate with analyzing the theoretical part on your own, and you initiate. That's why I have dared, I should say, to come and present over here.
Okay.
Yeah.
The other question is related to the water molecule. You find in some way the representation of the angle between the two OH.
In the figure you are saying?
Yes. Thank you.
This one?
Have you found some values about this angle?
No, not yet. Yeah, 105 is given. It's
Yes, but if you find some values, have you calculated from your model?
no, sir. I do not have my model right now because I have not studied it in deep till. So definitely, I would like to go to yours as well as Professor Arangazin's literature, and then I'll be having the solutions for this one.
Professor Perez Enriquez, thank you for asking the question. It's a beautiful question. This, this angle here is a mystery. In our paper with Professor Shiladi, we did not address. We addressed the statistically and with the variational model the water molecule is, you know, the magnetic dipole and the electric dipole. We got the correct sign and the very, very small value. However, this remains a mystery, and if anybody can explain this mystery, the mystery of this is, it's extremely important from an environmental viewpoint. For instance, the HHO gas, the brown gas. Apparently, in the brown gas, because basically it's a gaseous form of water, the brown gas. Apparently, one of the effects that are at the foundation of transforming water into this combustible gas with no catalyst, just is the manipulation of this angle. Because the moment you reduce this angle, this is north and south, they will attract. The water molecule automatically passes into the gaseous state. It's enough to turn it into a gaseous state. And then it becomes unstable. And then apparently the two hydrogen atoms decouple from the oxygen. In other words, apparently, but there's been no quantitative work. If any, you are an expert now. Maybe you can do this
Yes.
calculation. We will provide research funds for you, and anybody wants to calculate. But you seem to be the leading expert in the field. From your presentation, again, let me review the mechanism, this electrolyzer or whatever the machine it is, has a number of mechanisms. One of the mechanisms is the elimination of this angle and turning this vertical. If you look at my paper on the HHO gas, you will see a picture in which those two are together. Once they are trying, no, they should be, normally they should be, because here is north. Now, let me back up. First, according to experimental evidence, nothing to do with quantum chemistry, nothing to do. I mentioned this here also in my talk. The hydrogen atom, when it's part of the hydrogen molecule, does not have spherical distribution of the orbitals. This has been published in various books, and it has precisely this toroidal form. So therefore, it possesses this magnetic moment. And so, because of this magnetic moment, a magnetic moment also north and south should attract. In other words, there is a structure. Water molecule is the most complex in the universe. There is some strange reason whereby this the only angle for which the hydrogen can couple to the oxygen, apparently. Now, once we know the reason for this number, then we can turn water into a combustible gas. Again, because then the moment they collapse by using the trigger, the external trigger, plus this attraction, the coupling of the hydrogen decomposes. And water is turned into a combustible gas composed of 2/3 hydrogen and 1/3 oxygen. So I strongly recommend thank you, Professor Enrico, for asking very, very important question, and you identified an unsolved problem, which as environmental problem. Thank you for your.
Thank you, sir.
Any other question? Yeah.
Okay. I would like to know where is the rest electrons functions for oxygen here in this picture.
What is the question? I do not understand.
Oxygen atom has more electron. Here only show two wave function for two electrons. But other electrons, where?
Prayers.
The oxygen has only two valence bonds. There are many, many electrons, but they are not available for both.
But it's, I wonder where is the rest electron? Not valence electron. Because electron configuration, it's strange picture for me.
Maybe the other electrons are, yeah.
Strange picture.
Yeah, one can imagine that they are all coupled by pairs also in the core. Yeah.
But are not available.
Yeah.
Okay. I completely agree that your presentation was beautiful, but maybe it was a bit fast for non-specialists in this area. And in this respect, I will ask maybe a bit stupid questions about isoelectronium. Your presentation implies that the formation of isoelectronium is possible for electrons bound in electric field of nucleus. Could you please give me a mathematical restriction on formation of isoelectronium for free electrons? And second related question, does the formation of isoelectronium can contribute to explanation of superconductivity, especially in new high temperature superconductors?
Yeah. What I have given over here is the formation of the use of isoelectronium just to remove the insufficiencies or give the addition or overcome the insufficiencies of quantum chemistry. I have not solved any kind of mathematics, and I have not tried to give even the mathematical solution of isoelectronium. So regarding superconductivity, I have not yet gone through. So maybe, Professor, you can.
To me, it's very attractive possibility to suggest. To me, it's very attractive possibility to suggest on the basis of isoelectronium any explanation of high temperature superconductivity, because.
Let me elaborate first the first question. Again, this is connected to the mystery of the valence, which in turn is connected to the mystery of the Cooper pair, in which Professor Animalou is the master in this. And basically what hadronic chemistry provides a quantitative representation that provides an exact representation of binding energy. But if you ask me if I had understood the mechanism, I have to honestly say no. Because basically what happened is that you have two hydrogen atoms. Once the two hydrogen atoms are together, then for reason that I do not know, the reason I do not know, you have this mechanism that I call Animalou-Santilli mechanism, whereby they bond together strongly. Remember that the two identical electrons should repel each other. Yes, should repel each other. So the moment the two electrons, the wave packet of the two electrons penetrates one inside the other in singlet coupling, however, in triplet will repel, but in singlet, the moment this activates the strong valence force that our colleague has described. But this is particularly occurs only in the presence of the nuclei. In the absence of nuclei, so quantum mechanics has a very crucial effect in the mechanism. Hadronic mechanics is only the isoelectronium. And the next question, the other question, yes, the other question, very important. Yes, you have touched the finger. You see, the ideal current, superconducting current, it will be a current of isoelectronium, namely of pair valence electrons, or two valence in singlet coupling. Why so? This is the ultimate superconductivity. Why so? Because, first of all, the spin is zero. You see, part of the electric resistance is due to spin, because the spin creates all sorts of interaction with matter. But not only that, the biggest disturbance in the propagation of electric current is due to the magnetic field. So the isoelectronium has zero magnetic field, has a double charge, but the zero magnetic fields. So basically you eliminate virtually all the stray fields that occur in the propagation. So the current of isoelectronium, my God, will be superconducting at 2000 degrees. And the problem is, a problem is that once that's the mystery of nature, once you remove the protons, the isoelectronium is unstable. And I tried to do calculation, and we got instability. Otherwise, we would have proposed an electric current made of isoelectronium. At superconducting, we could not, because the isoelectronium became unstable. However, it remains, Professor Animalou, you are an expert in superconductivity, you have an imaginary, there could be, however, a conductor, quote unquote, not made of metal, this could be a plastic, because this is zero. You don't need an metal to conduct, to propagate the isoelectronium. So it could be plastic, could be everything, could be animal, but a conductor that constrains the two electrons to remain in the isoelectronium form. Then that was the part that we worked on the isoelectronium, but we did not work on the conductor that will maintain the stability of the isoelectronium. If that is possible, thank you for your time.
I understood, but I'd like to add and to inform that in recent research of our laboratory, just we have found a so-called high-temperature Kondo effect in novel iron arsenide superconductive materials, which indicates that there is a strong coupling between electrons and doped elements. Which doped elements, impurities.
Doped.
Yes, we also, this is a novel effect. As impurities, you know, for example, in novel superconductor iron-containing materials, the superconductivity appears only when we dope some elements in the structure. And thus, the presence of high-temperature Kondo effect, in this case, indicates that there is strong interaction between electrons and the impurities caused by these doped elements. And therefore, maybe in this case, there appears some possibilities. This is not only like a qualitative idea, to describe an either electronium as a stable element near.
Let me elaborate. Yeah, this is an excellent point. Yes, let me, incidentally, we have funds for do research in what we are discussing, including for you, Professor Kolminski. Our negative result against an electric current made of isoelectroniums refers to the propagation of isoelectronium at long distance, say a mile, and refer under the assumption of having ordinary matter, no special conductor. Now, however, when you go locally in the vicinity of atoms, absolutely, absolutely, not only that, a number of elements naturally release the electrons in pair. In other words, we have to go to the Pauli principle, Pauli exclusion principle. Look at the helium. The helium has 2 electrons. Those two electrons are not one here, the other there. No, the 2 electrons are paired, and they apparently orbit most of the time together in an isoelectronium form. This point is so true that when you do the photodisintegration of the helium, the 2 pair electrons, they even come through the barrier tunnel. They come out in such a form of a pair. So when you go at the local level of superconductivity, positively the isoelectronium play a form. As a matter of fact, whatever gain you get in the temperature, you can reduce that gain to the percentage of the electrons coupled in the isoelectronium form. Again, for very clear reason, because once you are on the isoelectronium form, you have a pure charge and 0 magnetic moment. So you move much, much faster. Then and only then, so yes, locally you do have isoelectronium, absolutely. Yes, very interesting. Thank you for this, very, very interesting. We would like to support this research.
Okay.
Anybody wants to come up?
Thank you.
Okay, there's another question here. Sorry.
Would you show the structure of water molecule there? My question is very simple. The most peculiar property of water is that it has its maximum density at 4 degrees Celsius. And it is very difficult to explain it by the classical approach of the structure. Yeah. The most peculiar property of water is that it has its maximum density at 4 degrees Celsius, that is anomalous behavior. Can this approach explain this anomalous behavior?
Repeat the anomalous, I'm sorry, I apologize.
Yes, the maximum density of water at 4 degrees Celsius centigrade. I mean, this is a peculiar property, it may be related to
No, we do not know. It's a big mystery. Yes.
not in the purview of this I think this question is not in the purview of our mechanics. Actually, it is a collection of molecules. They behave together. Their temperature is lower down, and then there is arrangement taking place. It is some sort of crystallization type of situation is there. And tetrahedral arrangements are maximum achieved at 4 o'clock, 4 degrees Celsius. Yeah, and then further it solidifies, it makes it more rigid that way. Anyway, tetrahedral arrangement itself is a rigid one, and we know the ice is as hard as diamond, provided we don't take proper precaution, isn't it? So this is nothing to do with our mathematics, isn't it? Because we are doing at a 1 femtometer, isn't it? And this association is much larger because there is hydrogen bonding between oxygen and oxygen is taking place, and they get oriented around one oxygen molecule in a tetrahedral fashion. So tetrahedral arrangement is always harder than any other arrangement.
Can I have a comment on this?
Yeah, please.
But we know that the aggregation of all the molecules, it strongly depends on the structure of the molecule itself, because the interaction with other molecules is determined by the structure of its molecule itself.
Yeah. In that, I would like to say that the lone pair which are existing on there, they are the seat of forming hydrogen bonding, isn't it? And they initiate this tetrahedral structure. They initiate. And that hydrogen bond distance is much larger than normal oxygen-hydrogen bond. You see?
I would like to say the comment on
Yeah,
that.
please.
Here, let's. The issue is a very important issue of the maximum density at 4 degrees is connected to the liquid state more than the individual water molecule. Now, my personal opinion is that the liquid state is what we call a Magne liquid, namely as the structure of a molecular bond, not a valence bond. What in quantum chemistry they use H bridges. For me, this is nomenclature because there's no quantitative treatment. What I do tentatively, at least I do some quantitative, not necessarily the final version, but at least I have something. I want to see explicitly, again, as for the valence, for the liquid state, I want to see, show me the force has got to be attractive. Where is the originated force? H bridges, all nomenclature. I'm very, very unhappy about this. Now, in my opinion, if you cap this water molecule and you reverse it, and you will see that you will see the other hydrogen atom coupling with this in this sequence, south, north, south, north. So here you have a clear. Now again, this is a natural state of water in which there are those two magnetic moments available for coupling. This is which are so once you have another hydrogen atom on the other side, and you clearly then you have an explicit force, attractive force, exactly like the one in an elementary molecule, and the same can be done on the other side. Another reason why, for me, the liquid state is a molecular state created by this magnetic moment is that all magnetic effects die at a certain temperature called the Curie temperature, as we all know. Therefore, for me, at the boiling temperature, 100 degrees, the boiling temperature of water is the Curie temperature of those magnetic bonds, period. It's just that simple. But this, before you have the orthodox chemistry community accept such evidence, forget about it.
Any other comment?
Now the density, maximum density that the open problem can be quantitatively with equations addressed with this type of molecular model of the liquid state, because you have has never been done, but predict at a certain temperature you have an optimal of configuration which will be 4 degrees, predicted to be 4 degrees. If you are higher, you have disturbances, so clearly the weight decreases and the density decreases. If you go below, then you approach, you activate a transition toward the solid state, and you enter into other, it's a question of optimization. Professor Aringazin, with your variational techniques, it should be quantitatively treatable.
Yeah, but...
Sorry, but again, help understand the water molecule, because this implies new fuel, new clean fuels. Industrial applications are enormous, enormous.
But I think also that the classical explanation of those microstructures near the zero, near the freezing point, is the electrical dipole. So that the hydrogen parts, you know, they tend to electrically bind to the positive. It is to the negative, the negative oxygen,
Absolutely correct, because here not only you have a magnetic dipole, but you also have an electric. You also have an electric dipole here. Absolutely, very true.
Okay. I think me. And we are very happy that this meeting happened, and we wish you then a good trip back home.